So yesterday we went through questions 1 through 10 on your review. Let's go over the rest of it. Toward the end of class, I had you guys write some formulas over here. I had you guys write that voltage equals current times resistance. We can rearrange that formula so that we know that current is voltage divided by resistance. And then another formula you're going to need is for power. And power is current times voltage. Okay. You might also want to add over on the side of your paper somewhere, just so you have it, that voltage is measured in volts. I stands for current, and we measure it in amps. I know that I already did I. R is resistance, and we measure it in ohms, OHM, or we have this symbol for ohms. And then power is measured in watts. Okay. All right. So let's go ahead and look at our questions and start by picking out our givens. All right. I am given here that there's a 12-volt battery. V is voltage. Okay. And a resistance of 124 ohms. So the unit is ohms, so that means that R is 124. And it says calculate the current. So I want I. I is my question mark. All right. Since I want I have V, I have R, I'm going to use this equation right here because it's I equals, and so I'll just have to do some calculations. So I equals V over R. So then I'm going to substitute in those numbers. I equals 12 divided by 124. So my answer, I equals, let me plug it in a calculator. $12 divided by 124. 0.0967. I'm going to round it to 0.0968. And for current, my units are going to be amps. That is my answer. All right, moving on to number 12. It says what voltage is needed to produce a 23 amp current. So that means that I equals 23. In a circuit with a resistance of 8 ohms, so R equals 8. And my question asks what voltage? So V is a question mark. Okay. Since I'm finding V, I'm going to use this top one. V equals IR. V equals 23 times 8. All right, V equals, let me plug that in the calculator. 23 times 8, 184. Voltage is just measured in volts. There's my answer. All right, one more. What is the power of the circuit from number 12? Well, number 12, I've got just the same givens. I equals 23. R equals 8. It's supposed to be an equal sign, but now I know what V is. I know V is 184. And what is the power? So power is what I want to find. So I'll use this equation here for power. Power equals current times voltage. Power equals, let's see, I is 23. Voltage is 184. All right, let me plug that into a calculator. 23 times 184. 4,232. All right. There we go. $4,232. Power is measured in watts. Okay. Now, let's go to the next one. All right, explain the energy transformations that happen when a magnet moves in a coil. All right, a magnet is moving. Moving is kinetic energy. We also call it mechanical energy because you're actually using it to do some work. And it's going to move in a coil of wire. If you recall that simulation we did, or think about that hand crank generator, this mechanical movement of a magnet will create an electrical current. So that's going to be electrical energy that gets produced. So that's the coil of the wire part as electrical energy. And then if it's connected to a light bulb and there's an electrical current, the light bulb is going to light up. So we're going to end up with some light energy. All three of these types of energy are types of kinetic energy, by the way. All right, explain the energy transformations that happen in a simple motor. Well, if it's connected to a battery, you're going to start with some potential chemical energy. If it's connected to an outlet, there's potential electrical energy. But either way, there's going to be some electrical energy produced. Some kind of electrical current. And then if it's connected to a motor, we're going to take that electrical energy and we're going to turn it into movement. Movement that can do work. So that's going to be mechanical energy. Okay. And draw a magnet with its magnetic field lines. So if we have a bar magnet with a north pole and a south pole, the magnetic field lines are going to go from north to south. Okay, and you're going to most easily see that in these kind of middle field lines. Some of the ones out toward the edge are going to look like they're just going out straight, but they're going toward the South Pole. You could probably find a better image if you Google image search this. And if I had a big giant piece of paper to draw this on, we would be able to see that all of these lines eventually curve back to the South Pole. All right, that's everything that's going to be on your test. Make sure your review is complete. Turn it in tomorrow for extra credit. You can also use it to help you on your test.